please welcome Chad Carlisle, Regional Vice President at MongoDB.
Ain't nobody tell me nothing. You can't tell me nothing. Can't nobody tell me nothing.
Good morning. How's everyone feeling? Great. All right. Welcome to MongoDB Atlanta.local. Thrilled to have you. My name's Chad Carlisle, and I'm Regional Vice President of MongoDB. And on behalf of every MongoDB employee, I want to thank all of you for being here today. You know, we don't take lightly that you've taken time out of your work schedule to spend the day with us. So our return commitment to you is we want to give you a welcoming place where you can learn, where you can network, and throughout the day, ask our experts about the best way to build your next big idea with MongoDB. So we hope you get a lot out of today. And while today will be packed with content goodness across the program, we do want to encourage you all to register now for MongoDB World and secure your pass at the early bird rate. Now, MongoDB World returns to the great city of New York, our home. The dates are June 17th through the 19th. It's June 17th, 18th, and 19th. And we've polled all of our attendees for the last couple of years. And in response to what they've asked, we've added a lot more developer tracks to the program. We've added deeper technical talks, and we've added a third day to the event. Registering with your code LOCAL, which you'll see right here, will give you 25% off on your registration. So that's a $500 early bird rate today. With 25% off, it's $375. After Friday, it's $900. So you don't even need to be a sales guy like me to understand that's a great deal. So slide on over to mongodbworld.com and register today or throughout the day. Some housekeeping on Wi-Fi. Our Wi-Fi network, if you haven't joined it yet, is MongoDB, and our password is .local, all caps. .local, you will get asked that again today. And if you've ever spent time with us, you know we like to party. So join us for the Arctic Room, which is a really cool setting, at 4 o'clock for a happy hour. You can talk to me and some of your peers. Great place to network. Come for one, stay for 3 or 4. Make sure you have your Uber and Lyft apps handy. And at the conclusion of your last breakout session today, I want you to check your inbox for a feedback survey. So MongoDB has been doing community events like this for 9 or 10 years. Like a garage band, we kind of developed our roots in the community. So it's important that you are giving us the feedback we need to make these events valuable for you. So complete the survey, and on your way out, slide on over to the registration desk or booth to pick up your swag. So this is our first return visit for a community event to Atlanta since April of 2012. So by a show of hands, who was here that day? Wow, I was here. I'm the only one in the room. So in April of 12, it was April 20th, we were down on the campus of the Georgia Tech Research Institute, and I remember it for 3 primary reasons. The first is I was interviewing at the company this day. And so it was an interview, and I showed up in a suit. And needless to say, I stuck out like a sore thumb. Clearly, I wasn't there to network with some of the developer community there. I was trying to get a job. But I was amazed at the time to learn that 150 people showed up about this technology that I just recently heard about, this wild idea of MongoDB. And what struck me, and still resonates to the day, is a conversation I had with one of the attendees that day. And doing my due diligence on the company, I said, hey, like, what's unique? Why do you like MongoDB? And he said, you know, as a developer, I just love how the database gets out of my way and allows me to be efficient. And he told me at that day, he said, you guys are a little bit ahead of your time. He said, the world is moving to the way in which you guys are managing data. And of course, he was talking about rich support for JSON and the document model and all the things that we've come to know and love about MongoDB. But he said, the world is moving to the way that you manage data. And that really struck me as something that, like I said, stays with me today. And that value proposition, almost 7 years to the day, still holds true. MongoDB gives developers the best way to work with data. We allow our users to intelligently put data where they want it around the globe, and we give you the freedom to run on any platform, from a laptop to a mobile device to a mainframe to a cloud. And here to tell you about all the great things that are coming in our next wave of MongoDB innovation and show you some details is our VP of Products, Servers, and enterprise tools, Dr. Grigori Melnik.
I'm a man on a mission. I'm a man on a mission. I don't need no permission. I'm a man.
That's right. I'm on a mission. I'm on a mission to convince you that MongoDB is the best database for modern applications. That's a bold statement. So let's decipher. First, what do we mean by modern applications? Well, we believe that modern applications need to be based on these three fundamental tenets. The database needs to support superb developer productivity. You shouldn't be wrangling around the database, right? It should feel natural. It should support infrastructure agility, regardless where you run it. Again, anywhere from mainframe to clouds, anywhere from mobile device, and even a Raspberry Pi, you shouldn't need to rewrite your application code that deals with data. And the last one is uncompromising user experience. And what do we mean by that? Well, first and foremost, of course, is the latency, making sure that the data, you can access the data and process it in a very, very quick way. But also supporting your style, your way, your way of coding. So that's why we have a very, very rich ecosystem of drivers and ODMs and other tools. In fact, I remember my first day at job when I looked at the inventory of all the different drivers that my team had to support. I was like, oh, holy cow, it's 35 or something. I was like, that's a lot. Let's start looking at some of the older ones. I was naive in a way, and I said, hey, let's deprecate some of them. And of course, then the founders told me that, well, no, that's actually at the core of our culture. We actually want to be a database for every developer, regardless of how large or how small your developer community is. So now, how does MongoDB support these three tenets? Well, it's all come down to three core principles. First, the best way of working with data, our document model. The second one is the way our distributed systems are designed. And the third one is the ability to run everywhere, okay? So with the document model, let's start with that. What do we mean by that? Well, think about the documents being at the heart of MongoDB, starting from day one and today. The best way of working with data, it's natural, right? So you think about how you model your data. You think about objects, right? You think about, object Grigori. You don't decompose Grigori into rows and columns, right? Please don't. So it's way more natural to think of objects in form of documents. Also, lots of programming languages support inherently data structures to deal with the documents, whether it's whatever you've got in your language there, but it's very, very natural. The dynamic schema allows you not to be stuck, right, with the decisions that are made early on. If you remember the old days of SQL where you didn't even have the alter command, right? It's all very much like you spend your time, you design everything up front, you proof it, you get to the point of whatever your third or fourth normal form, and then you run with it. Well, that's not the game in the town today, right? You want to have the agility. You want to be able to react to the new requirements. You want to be able to modify and move quickly. So now, having said that, while you do have dynamic schema in MongoDB, we also do provide validation, schema validation. And with the support of the JSON schema validation today, you can be, again, as fluid with your database schema or as strict and prescriptive as you'd like. And the last one is the super powerful query language. MQL, MongoDB query language, and the underlying aggregation framework is a magnificent piece of work. It gives you ability to query in a lot of different ways, a lot of power, and again, dealing with the hierarchical structures inside of the document model, super powerful. Now, with the distributed systems, what's included? Well, with MongoDB, you get all of these, high availability and scale out and workload isolation and zone charting. And this is not something that you need to kind of bolt on top of the database. This actually comes with the database, right? So with the scale out, you want to be able to scale elastically up and down in reaction to the different spikes in workloads. With the workload isolation, you want to separate your transactional workloads from analytical workloads. You don't want some raw query to bring down a transactional store. And with the zone sharding, you want to have the flexibility of keeping the data where it needs to be and dealing with the latency requirements as well as with regulatory requirements. And when we speak of runs everywhere, well, first of all, of course, we mean the consistency of experience. And this is the consistency of experience of the developers who built with MongoDB. Again, the old promise of Java in 1995, write once, run everywhere. Well, this is something that we're actually living and embodying today with MongoDB. You do not have to rewrite your code regardless of the target platform where you're going to be deploying it. Portability of your code, as I said. And then, of course, the other thing is enterprise-grade security. That is the key here. All right, so what we're going to, well, actually, so with all of these three key tenets, we actually believe that the MongoDB is the best database for any use case. It's a general purpose database for any use case on any platform. The rest of the morning, what we're going to do, I'm actually going to focus on each of these tenets and tell you what we have done in 4.0, our last release of MongoDB, and what we've actually been working on in our upcoming release 4.2 to make each of these, the documents model, the distributed systems, and then the ability to run everywhere better for you. So first up, documents, the document model. You may have heard that in 4.0, we have shipped transactions. Yes? How many people are aware that MongoDB now supports ACID transactions? Well, not that many. Well, there's the big news for you. That was actually like the last big frontier for us to conquer. So now, if you think about it, for many years, we've been saying that the document model itself negates the need of transactions in many cases. But there are some situations where you do need them. So let's take a look at the example. So let's say I have a catalog, or well, actually not the catalog. I have an order here, and I'm doing the insertion in the order, and I also want to make sure that when an item ships, I get the inventory update, right? So now this is all fine, perfectly fine. But what happens, if you get an application crash here, right? Or you get an application crash somewhere here, right? Well, your data suddenly gets into inconsistent state, right? Your order collection may be updated while the inventory hasn't gotten updated, right? So, not a big deal, and people know how to deal with this. But in a way, in the past, you would have to handle all of these. You would have to do, some of the coding and write all this logic to handle this survivals, right? Well, with transactions that we have introduced in MongoDB 4.0, now we can actually take care. The database will take care of that. Now look at what this does, right? It starts a transaction, then you go through your list of actions, and then you just commit a transaction. There is actually nothing new. I want to be very, very clear. With the introduction of MongoDB transactions, we haven't invented a new type of transactions. These are your old good transactions that you're all used to, okay? Just working in the modern world of MongoDB. They're very familiar. There's nothing fundamentally new there, okay? They're also conversational, so within the transactions, you can do all kinds of things. You can do read your own writes, you can do all of that. That's all fine. And they're also fast. They're actually quite fast, right? So how fast are they? Well, when we were designing transactions, when we were building that in 4.0, one of the design criteria was make sure, first of all, that the introduction of the transactions doesn't slow down any of the non-transactional workloads. That was almost like, a no-brainer, right? So what you see here is that we have designed a benchmark called Socialite, and it's on GitHub. You can check it out. You can actually run it yourself. In fact, we encourage people, right, as part of your perf testing and load testing, go, run it, of course, on your own workloads, but there's no reason why you cannot go and run the benchmarks that we have provided for you. So what you see here is that the blue bars are the 3.6 and the green ones are the 4.0. And you can see there's 4 different scenarios that we're testing in this benchmark. And in most cases, the performance is the same. In case of scenario 1 in 4.0, it's even better, just because we made the database generally better. With every new release, we're actually trying to make the database more performant. But this is where you do not use the transactions yet. What about the transactional workloads? Well, that's the second chart, okay? So what you can see here is that the similar logic when you were not using the transactions, and then the one when you were using the transactions, there's like a price that you pay, which is 2% or so, negligible, okay? Now, that's on the Socialite benchmark, but we thought, okay, well, we can do a bit better. What about some of the established benchmarks? So some of you may be familiar with the TPC suite of benchmarks, especially the TPCC. That one's been around for at least 20 years, if not more, 30, but maybe even. And we actually have done our testing and benchmarking using TPCC. Just one caveat I want to mention is that the way the TPCC is formulated is actually kind of against the best practices of modeling data with MongoDB. So we have to take TPCC and update it. Okay, so for example, the rule number 1 of TPCC is that your data has to be in the third normal form. Okay, well, that's not what we recommend, right? We recommend embedding, and again, data duplication is fine. So now, I'm not going to go in the details of this study, but I do encourage you to check out the entire paper, which, by the way, was accepted in VLDB, that gives you all the details of running TPCC against MongoDB. Great. So multi-document ACID transactions became available with 4.0 last June. People have been running them for a while. But what about sharded clusters? What about sharded deployments? Well, this is something that's coming up in 4.2, but you don't have to wait till 4.2 GAs. If you want to go and try the MongoDB, we call them global transactions in sharded clusters, you can actually sign up for the beta that is open to you now. Please try it out, give us some feedback. Awesome. So when should you use transactions? Well, let's start. I'm going to kind of drive this point home a few times. The fact that we've given you transactions doesn't give people a license to turn off their brain and start modeling poorly their data. You still need to think about your query patterns. You still need to think about what you're doing. But here's one example. In fact, let's start with the counterexample. Say, I'm modeling my orders and line items, and you can see the relationship here, right? Primary foreign keys, I have the line items with the order ID. Again, everything seems to be pretty straightforward. And this would be the example of the same thing in MongoDB. Have 2 collections, and say, I want to go and keep those 2 items in sync. So I may want to do something like this, okay? This is a totally legit code. This would work, okay? You can definitely wrap this in a transaction. However, this is exactly what you shouldn't be doing. This one kind of going back to the way you should model data in MongoDB, okay? And by the way, we have a phenomenal course on MongoDB University dedicated to data modeling, okay? I highly encourage you to check it out. I forgot the number, but it has data modeling in its title. So now what should you do? Well, here's what you should do instead, okay? You should actually embed your line items inside your order collection. And then you can do something as smart as this if you want to do the update. And this is perfectly fine because we do support manipulation of arrays inside of the update, okay? So now, why does it make more sense to do this? Well, because the line items and orders, they live together, okay? And this is something that you should keep in mind when you are designing your data and when you're thinking about the transactions. Transactions make sense when you are dealing with distinct business entities, right, or distinct bounded contexts, and you need to keep them in sync. If it's something that belongs together, then you should model it together, and then the transactions are unnecessary, okay? Please remember that. So if you're dealing with distinct business objects, so again, maybe you have an order collection and then have an inventory, those are separate. But orders and line items inside the orders, those kind of together, right? The other example where you would actually want to use transactions is that if you have some auxiliary collection that represents some rollups or views, okay? And you have the requirement of keeping them up to date in real time. So you would want to wrap those updates in a transaction. And then the third case, and this is actually something that makes more sense than for 2. This was actually more of an internal reason for us, because this is something that we're doing, is when you actually want to modify the short key values. Okay, so those operations would be wrapped in the transactions, and it makes perfect sense. And by the way, when I say modified short key values, I do not mean automatic resharding. That's not what we're doing in 4.2, so don't salivate over that yet. Okay, now if you want to learn more about the use cases and the patterns when and how to use MongoDB transactions, please attend the talk by Ben later today. Okay, great. So transactions are awesome and quite interesting in isolation, but what happens if you join transactions with the $ lookup? Yes, and that's like, nobody ever laughs. I know it's supposed to be a joke, because $ lookup is how we do joins in MongoDB. So if you're not familiar with that, just keep in mind, yes, MongoDB does support joins, left outer joins, and this is what you do. You use the $ lookup operator from the aggregation framework. So, and actually, with that, you can model your relationships quite well, quite nicely. So, in fact, we claim that MongoDB is the best database for modeling your relationships. Why do we say so? Well, think about it. In the relational database, the only way of how you can model your relationships is by reference, right? Just like in that example that I showed you earlier. Primary key, foreign key, relation, that's it. In case of MongoDB, you can actually do the same thing. You can do it by reference, but also we give you the ability to model your relationships through embedding. So we kind of give you 2 different ways of accomplishing the same thing. All right, so those are the documents, and they're pretty intuitive. And now, the aggregation framework that I mentioned a few times that we have built and that is part of the MongoDB query language, it's very powerful. Well, first, it's powerful because we modeled that aggregation framework from the Unix pipelines. Here's one of my favorite pipelines that you can probably grok what it does. Take a look. What does this pipeline do? Looks at some, I don't know, let's say MongoDB logs, right? Sorts them out and then gives me the top slowest operations. Most of you should be familiar with this, right? Whether, again, you're using Unix pipeline or PowerShell in Windows, same thing. The nice thing about the pipelines is that you are able to use small utilities, right, that can do something powerful on their own, and then you can assemble a more comprehensive pipeline together. So they're composable. They're debuggable as well, because you can actually debug and troubleshoot each of those steps, each of those stages in isolation. And they're quite powerful because you can do a lot of stuff. So just like in the Unix pipeline, the aggregation framework in MongoDB has a lot of powerful operators. And we've actually made them even better. In 4.0, we've added date manipulation functions, date manipulation functions, date manipulation operators to the aggregation framework. Also, we've improved and added a bunch of string manipulation operators, additional ones, because everybody knows that 80% of developers' time is spent futzing with the strings. And we also introduced type conversions, okay? So now, if you were to take that example that I showed you in Unix and turn it into the MongoDB aggregation pipeline, here's exactly the same thing, what it will look like in MongoDB, okay? Now, this is great. This is easy. You can read it, you can grok it, you can interpret it. But imagine if I had 10 of these operators, so 20, right? So kind of working through them and understanding what's going to happen and troubleshooting could be somewhat tedious. Wouldn't it be nice if I could actually do that somehow visually, where I could take each operator, each of these powerful operators in the aggregation framework, right, and see how I can apply it to my collection and preview the results, right, and then do it one at a time and then turn them on, turn them off, move them around, and see the impact that that's doing on my query. Wouldn't that be great? okay, I don't know, tough audience. I mean, I'm worried that you might be dead inside. So anyway, I know it's morning, but well, in order for you to truly appreciate it, we're actually going to give you a demo because you can do that. We built the aggregation pipeline builder inside Compass, which is our GUI. And for you to truly appreciate it, I'm very happy to invite Karen on stage to give you a demo of the aggregation pipeline builder. Come on up, Karen.
Say you know me better than I know myself. Say you know me better than I know myself.
Okay, thank you, Grigori. I am thrilled to be here today talking to you about how easy it is to use Compass's aggregation builder. Regardless of your skill level or your experience working with our aggregation tools, you'll be able to build up some sophisticated and powerful pipelines with this easy to use and easy to understand interface, and then integrate them seamlessly into your workflow. So to demonstrate this, I'm going to start by showing you a very simple aggregation on the reviews collection of a hypothetical e-commerce application database I have. So as you see here, or not, hold on. Okay, demo gods, come back to me. Just give me a second to play around here. Documents are here. So as you see here, I have all the documents. I'm on the Documents panel. And if I go to the Aggregation panel here, I should be able to see okay. As I go to the, so I can see all of the documents I have for my pipeline here. And if I have a very large collection, I can turn on sample mode. And then in this left column I have, this is where I'm going to build out my aggregation pipeline. So as I started typing in the stages here, you can see that because I have comment mode turned on here, once I select a stage, it's going to go ahead and show me all the fields inside my document that that stage can accept, whether they're an option or not. It also provides me with a brief description over all of those things. And if I need more information than that, if I click on this I button here, that's going to take me directly to the appropriate page inside of the MongoDB documentation. So having these two available at my fingertips while I'm working will surface to me exactly the information I need, as much or as little when I need it. So I know that the best aggregations, I'll start with a match. And as I start typing in the field name, you see that Compass auto-completes suggestions for me. Indeed, I'm going to use category for apparel. And as I finish typing in that here, you see in my live preview panel on the right, it goes ahead and matches that for me. So I can see how this match has affected my data, and that all of these documents here are indeed of category apparel. Now, once I have finished using a pipeline, I can collapse it here if I need to, and then I can continue working on my stage, working on my pipeline. So I'm going to add a new stage. I'm going to call it group. And then I am going to group by my name of my product. So what I want to do here is, I mentioned it's a reviews collection. So I want to figure out the average number of stars that my reviewers have given my products by their name. So I'm going to use stars as my field name. My accumulator will be average operator. Oops. And then here you see in the preview panel that I have all of these documents. I can surface to me and get insight into how my products are being reviewed by my users. And so having this sort of live feedback as I'm building everything out makes debugging and troubleshooting a breeze. So if I wanted to save this pipeline, I can, so I can continue working on it later. But instead, I'm going to go to a different collection, the orders collection. And I want to show you a much more complicated aggregation pipeline that I was working on earlier that I've yet to fully debug. So if I go to new pipeline from text, me go across here. I can go directly into my text editor, copy that code, go back, and paste it in here. And you could see that Compass has taken that code already and broken it down into the appropriate stages down here below. So in it, I can see all the different stages I have. And I just want to take this time to sort of give you an idea of what it is that I'm trying to accomplish with this aggregation pipeline. I had mentioned that this is from the orders collection. So in my orders collection, I have sales data in it. So what I'm trying to accomplish with this pipeline is I'm trying to analyze how the revenue from my products will trend over time. So in this first stage, for instance, it's a match, so I only want to look at my completed orders. And then every orders document has an array of products. So my next stage, I'm going to unwrap that array of products. And then I'm going to group by state, year, month, and product category to bring me the quantity sold and total revenue for the different products. And then once I'm done with that, I'm going to continue grouping over state and year, month to bring me total revenue and create a new array by category. Then I'm going to project out the fields that I want. And then I'm going to sort in ascending order for state and year and month. But as you can see here, this year month data looks a little weird. I don't know what year month 1.4834E is. In fact, a lot of these year month strings, it doesn't look particularly helpful. I was hoping to get this format, this year month to be year-month string. So if I go up to my original data, I can see actually right away inside the date created field that some of these, for instance, in some of my older order documents, the date created field looked like second since epoch, whereas other documents, it's in this nice ISO date type. Well, since I'm working with MongoDB 4.0 and we have the support for the date conversion operators, this is not a problem for me if I'm using Compass. I can go ahead and add a new stage after my match by clicking on the plus, and I'll call it add fields. And I'm going to overwrite my date created field. And you see that as I type in sorry, maybe you don't yet, but I promise you, you will. So you see as I type 2, it'll show me all the conversions that we support. So I'm looking for toDate here, that's the one we're going to use. And date created. And then again, once again, you see here in the preview panel, the date created is now that nice ISO date type that I wanted all the way across the board. And to confirm, if I go down to my final results, you can see here in my final results that I do indeed have this year month as a year-month all the way across the board as well. And that's really the power of Compass's aggregation pipeline. I could build these complicated aggregation pipelines stage by stage, and with this live feedback mechanism, I can verify that I'm getting the correct results that I'm anticipating, and it makes troubleshooting a breeze. So now that I have the pipeline that I want, all I have to do is I have to bring it into the language that I want so I can put it back into my project. So this brings me to my favorite feature about Compass, and that is the export to language. Now with that, this pipeline I have is now in the language that I want. I don't have to do any typing at all. I don't have to worry about matching brackets. I don't have to worry about getting my operator syntax just right. In fact, I can even include the import statements if I want. So if I want to put this back into my work environment, I'm going to go to Java. I'm going to click the copy, and then I could just paste it directly into my code. Now, that's pretty awesome. That's like my favorite thing about it, and if you don't think it's awesome, then you're not paying attention. But as you see here, we have these different languages here, but because Compass is a pluggable architecture, you can download it and you could play with it, and we're hoping to get some nice pull requests from the community to support languages that you don't yet see supported up here. Now, regardless of whether you are a total noob to our aggregation tools or whether you're a longtime power user, it has never been easier to use and create powerful, sophisticated aggregation pipelines, and it is right now with Compass's aggregation pipeline builder. So download it, give it a try, let us know what you think, and I can't wait to see what you build. Thank you.
Thanks, Karen. So that's the aggregation pipeline builder. And when is it available? Right now. So next, let's, MQL is pretty powerful and it's great now, but sometimes it's something that's hard to get to. So especially if you're trying to think about issuing a MQL query from a browser, a mobile browser. So let's imagine I have a catalog, a e-store, and I'm building some filtering capabilities in this catalog page. So at the top you see the actual MongoDB query, and then in the query bar you're going to see the REST API that I'm going to be formulating here. So this is pretty straightforward, easy, and of course I need to provide some mapping in between. There has to be some kind of a logic. You can imagine the architecture pretty standard, right? So say I start adding some filters, okay? In this case, I'm adding more to my find, and let's say I want to add additional ones. So far, so good, pretty straightforward. But you can see how easily it can get pretty tedious and a lot of things that I have to take care of. Now I have to deal with ranges. If I start adding sorting, then I have to think about and dealing with the directions of ordering and all of that, right? And what I'm essentially doing, okay, is I'm maintaining both parts here, is that I am building, as I'm enhancing the logic of my catalog page, I'm building a REST-based query language, okay? So basically, I had my MQL, I had my beautiful, powerful, very intuitive, easy to read. Anybody who you give this query to, even somebody who sees MongoDB for the first time, can absolutely grok and understand what's happening here. And yet, in here, I'm building a REST-based query language, okay? Wouldn't it be nice if I could do this in some way without actually doing all of this? Okay, wouldn't it be nice if I could actually issue a MongoDB query directly from the browser? Well, you say that's a crazy talk. What about security? What about all the sanity checks? How do you make sure that you prevent the injection attacks and all of that? Well, in fact, you can. In fact, for this very reason, we build a separate service that we call Query Anywhere. And the way it works is depicted in this diagram. So it's available in Atlas. So, there's a native SDK for Android and iOS available. And it uses Stitch underneath with the embedded authentication mechanism and the declarative rules that you can take advantage of. So you have the power of full MongoDB query language, you have full integrated authentication, and declarative rules that work like this. So through the UI, you're able to define the different roles. In this case, you can see I have patients and doctors and nurses. And then on different fields inside your collection, you can define the different permissions, okay? And you can update them too, live, and all of that will be respected by the Query Anywhere in real time. So this is something that's already been made available to you. I highly encourage you to try it out. It's been available since 4.0, and it's one of 4 services that we make available for you as part of Stitch, okay? And I'll talk more about them. For people who are not familiar with Stitch, Stitch is our serverless platform for building modern applications, something that lets you go fast without building a lot of middleware, all this middleware glue. And if you actually want to learn more about it, we do have a dedicated session on MongoDB serverless that I highly encourage you to attend later today. Okay, now think about the way you are building the app. You've got your, some transactions going through. You've got some selling perhaps going on. You've been successful. Now you've got the bean counters who want to get into the data so that they can analyze the data, right? So let's talk about the analytics. For that, we actually offer you a number of options. First, we give you BI Connector. BI Connector is the easiest way to basically have somebody who already uses some kind of a tool and have that tool go against MongoDB data. It sits in between and it translates, and everything, like, again, you don't have to switch your toolbox. You can use Tableau, you can use Power BI, whatever you have. You can also use our ODBC driver, and everybody knows that if you have an ODBC driver, then it's pretty much anything you can plug in, particularly Excel, because everybody knows that probably 80% of all the analytical work is still done today in Excel. So in a matter of a minute or two, you can set up an ODBC source and get it going against the MongoDB. And we have ODBC driver for all different platforms, Mac and Linux and Windows. But there's a third option that I'm particularly excited about. It's a separate product called MongoDB Charts that we designed to natively go against MongoDB. And we believe this is the fastest and easiest way to actually get your data visualizations and data analysis going against MongoDB data. So you can see with this canvas, MongoDB Charts automatically recognizes the schema of your data, gives you the ability to drag and drop on the canvas the fields and produce a chart that you like. No coding required, pretty intuitive, very, very familiar to most people. Then you can grab those charts and you can combine them into dashboards. In the dashboard, you can choose to get like the auto refresh rate, or you can share the dashboards, and even more. The killer feature of MongoDB Charts is that you can actually take your data visualizations that you assemble using MongoDB Charts and then embed those into your applications or into portals, websites, what have you, okay, without writing a single line of code. So we will generate that snippet of code for the iframe or a piece of JavaScript that you would need to embed in your application. In this case, you can see I have a WordPress website that I would like to embed my interactive data visualization in that was built in Charts, okay? And you will see in a minute how easy this is done, okay? So as soon as I'm able to insert this, you will see it will refresh and I have the chart right there. Now, the key here, MongoDB Charts understands the fundamental model, how the data is modeled. So, you don't have to worry about flattening your hierarchies like the way you would have to if you're using BI connector and you have to drag your data into the Power Pivot inside Excel, for example. You don't have to do any of that. You don't have to deal with wrangling with the complicated and fragile ETL pipelines. And this is actually something that's available to you now in Atlas. You don't even have to install it. Just go ahead and use it, run it, take it for a spin. It's awesome. So, in the document model, we talked about asset transactions, we talked about aggregation pipeline builder, we talked about the stitch query anywhere, and analytics. Next up is distributed systems. In distributed systems, we provide high availability, scale out, and workload isolation and zone sharding. So let's talk a little bit more about zone sharding. Why is it important? Well, for two reasons. First, it's latency. Again, you want the data to be close to where you're using it. You want to be able to have the data in the region where you are actually querying the data. And the second one, of course, is the regulation, right? So think about countries like Germany and Japan, and I think Canada is following the suit where the data of those citizens cannot leave the geographic boundaries of those countries. So let's say you're building an app and you're starting your startup, you're building something, you first got the East Coast, deployed your data in the node somewhere on the East Coast, and you're becoming more popular and you want to accommodate now traffic coming from Europe. Well, you can use the zone sharding capabilities of MongoDB to actually denote some of the documents, right? You tag them, like EU-DE or something like that. And then, MongoDB will go and direct those queries to the second, another node that you will set up in Europe. And as you grow, as your site becomes more popular, you can add Australia and other places. But the key here to remember is that while MongoDB will do all of that, replication seamlessly and redirection of traffic, you still have to configure. You still have to do the maintenance on this cluster to make sure that MongoDB knows where to go. Well, we can actually do better. If you are using Atlas, we have a feature in Atlas called global clusters that actually allows you to do all of this automatically. And for you to truly appreciate it, I'm going to invite Tosin on stage to give you a demo of Atlas global clusters. Come on up, Tosin.
Thanks, Grigori. I'm actually excited to show this feature today, this global clusters feature. With this feature, you no longer have to be a household name internet brand to reach your users around the world. So, like Grigori said, to get started, I'm actually going to go ahead and build a cluster here. But first, I want to talk about a number of features in Atlas. You can select your preferred cloud provider and your target region and build your cluster there. Whether during or after the creation of your cluster, you can actually set or change the location of your cluster, and Atlas will create the cluster or move it for you. It's also important to know that all of this will happen with no change to your application, no manual intervention, and no downtime. You can deploy your cluster across multiple regions for high availability and cross-region resiliency. You can also create or add replica nodes to ensure that read operations are performed on geographically closer data. If you needed to run analytics workloads that don't compete for resources with your operational workloads, you can add nodes in Atlas that are specifically dedicated to analytics. Now, the global cluster capability takes things one step further. Within this view, within the global cluster configuration view, we've added a latency-aware map. Now, the opacity within the map indicates the approximate latency from users around the world to your target cluster. So you see here, we have a cluster in Northern Virginia, so the areas around Northern Virginia are highly opaque, indicating that users around the East Coast of US will have great write experience. However, users, say, in Australia won't have such an experience due to high latency. This potentially will lead to customer dissatisfaction, maybe even customer attrition. As you can imagine, customer attrition would ultimately impact your bottom line. The global clusters capability in Atlas actually uses the zone sharding feature in MongoDB that some of you may already be familiar with that allows you to partition your data across multiple zones. It's available on AWS, Google Cloud Platform, and Azure. You can create these zones yourself, right, by configuring them there, and you start from scratch. Or you can use some of the templates that we have available for you. And these templates merely create a starting point to get you going fairly quickly. So to show you how this works, I'm going to use the global performance template. So here you see that the Americas is mapped to Northern Virginia, EMEA to Frankfurt, and APAC to Singapore. This is that canonical 3-geo cluster that allows you to serve the world's population to write into these zones within this cluster. So imagine, say, your application grows, but really your Americas users are not really concentrated in Northern Virginia, but maybe perhaps on the West Coast. You can actually move the location of that zone. So let's go ahead and change Northern Virginia to, say, Northern California, and you see that that zone has been moved to Northern California. All this happens in the background, again, with no change to your application and no downtime. Now, say your application gains more popularity, you now have some users that are now concentrated, say, in Northern Virginia. You can add a new zone to support those users as well, right? So here we have our new Northern Virginia zone. Now you have the Americas in Northern California, another zone we just added in Northern Virginia. So the excellent global performance template here actually just gets you started serving a larger percentage of the world's population with low latency writes. There are a couple of things you see here on this map. First, there's these colors within the map that actually shows the demarcation across your zones. You saw that in the previous map as well. The other thing here is that obviously collapses a couple of the zones, primarily for user experience and readability. Within a few minutes, if I go ahead and deploy a cluster like this one, the Atlas console here looks like that of any other Atlas cluster. Within this connect experience, you have a stable connection string that can be used across all your globally deployed application instances. It's important to note that this connection string will never change regardless of changes that you may have made to your cluster topology. So this is really what makes symmetric application deployment not only possible, but also quite easy. The other thing we can do here is look at some data. Now, within this data explorer, you can do a number of things. You can create your database by giving it a name. You create your collection. You can also give that a name. This dialog also walks you through creation of a shard key. In this case, it's a 2-field key. The first field is a mandatory location field that allows data to actually go to the correct location. The second one can be one of your choosing. So in this case, for example, let's say we have a field called customer ID. You can set it to that. Right? Now, once you create that database, you load some data into it. The only thing you have to do to complete this setup is to add a location field that's set to your 2-letter ISO country code or subdivision code, right? This adds a location affinity to your documents, ensuring that each document actually goes to the correct geographical zone. So in this case, you see USWA's, Washington State in the US. That'll go to our North America West zone that we saw earlier. If we scroll down here, you have your location here, INRJ. That's the India-Rajasthan region. Now, the India-Rajasthan region actually is served out of the APAC South zone, which is in Singapore. If you look at Rajasthan here, it's actually less opaque, indicating that users around this area would have not so great write experience. Now, your application adoption continues to grow. You now have more users, say, in that India region, and you get to serve the users with low latency writes. We can actually add a new zone to support them, say, in our Mumbai region. So let's go to our Mumbai region there. You see that this setup has been remapped to ensure that surrounding countries are now being served out of this Mumbai region. So you see now that it's opaque, right? So that's good. Let's assume this application popularity continues to grow and the actual traffic in that Mumbai region grows beyond the capacity of a single shard. You can actually scale your write throughput to that region as well by adding additional shards. Let's go to our additional option there. So you could increase the number of shards. And while we're here, you can also just change the name of that zone to SA to indicate, South Asia, for example. And you see it over there, okay? To this point, we've mostly been talking about serving users with low latency writes. Now consider that users today expect a social interactive experience that allow them to interact with a global audience, not just with low latency writes, but also low latency reads. With a single click of a button, you can configure local reads in all zones. And what Atlas does in this case is that it adds a read replica for every zone in every other zone. Okay? What you have here is a truly global cluster with low latency writes and low latency reads. This essentially gives you a global operational data layer. As I mentioned earlier, if you think about it, the world is becoming more connected than ever, and you really don't want or have to be a global behemoth internet brand name to reach your users around the world. You can reach them right here within MongoDB Atlas using the global clusters capability. Thank you.
Awesome. Thank you, Tossin. So that's Atlas Global Clusters, and they're available for you now. And needless to say that the best way to run MongoDB in the cloud is actually to use Atlas. The easiest way, the most economic, the best way. So it's something that's been available since 4.0. Now, the next thing that I'd like to talk about as part of our distributed systems tenant is high availability, okay? Well, with Atlas, we actually offer an industry-leading SLA, right? 4.5 nines of uptime. And just to be clear, 4.5 nines, that corresponds to how many hours of downtime a year? It's not hours. It's 26 minutes at most a year. That's phenomenal. So definitely something that you should keep in mind. And we're working on constantly improving that. So in 3.6, that's been quite a while ago, we have introduced a concept called chain streams. And the idea of chain streams was to give you the ability to get real-time notifications about changes that happen inside the database, right? So, you can see the example of the chain stream in action here, where I may be watching for the inserts and replace operations, and also making sure that there is the match on a specific field where I want n to be greater than 1. So you can see that our chain streams are actually quite flexible in terms of how you define them. The nice thing about the chain streams is that they're designed to be resumable. So there's a resumability token that you can pass on, and everything is great, but from the HA perspective, chain streams cannot survive an application crash, okay? So we thought we could do better, and what we build is servers called triggers. We build stitch triggers that actually allows you to do just that, but in the modern distributed world with the high availability. Stitch triggers work together with stitch functions, and stitch functions, think of them as some JavaScript functions that you provide that do something useful. And again, that's part of this umbrella set of technologies that we call Stitch. 4 of them are listed here. So here's how Stitch triggers work. Say I want to monitor for some increments to my data that gonna get noticed by a trigger. The trigger is going to invoke a JavaScript function. That function can do something useful, whatever you decide that function to do. Say in my example, this is going to call a Twilio API that will turn and buzz my phone. Okay? So that's how easy and how intuitive Stitch triggers are. So in order for you to actually see them in action, I'm going to invite on stage, oh yeah, wait, that's me. So let's see how the triggers work. Let's rock and roll, please. So what you see in here, any second now, there you go. You see my triggers demo. I have a database here, foo, and I have a collection bar. And what I want to do, I want to define a trigger that once I add a document inside bar collection, it will actually increment a counter in a new collection that I'm going to call counter. Okay, so here's how I'm going to do that. I'm going to go and switch to the triggers. I'm going to add a trigger. Just going to go and follow. I'm going to give a name. I don't know, let's just call this trigger Inc. Right? I'm going to connect it to the cluster that I am interested in, choose the right database, the right collection, and then the type of operations that I'm going to monitor. In this case, it's insert. If I want to have some additional, like if I want the whole document to be supplied, not just the change event, I can also turn this on. And then I have to provide the function, either one from the predefined or I can build one. And just so you can see how easy it is to build it, we are actually providing you with the template here and walk you through this contextual guidance. But for what I am trying to do, all I need is actually this line. I'm going to delete the rest of this. And I'm going to make sure that I specify the right database here. So it's foo. Notice I'm going to be creating a new collection. Let's call it counter. Okay? And now all I'm going to do is return, and I'm going to do an update 1 on this collection. Okay, so let's just assemble a document. So I need an ID. I need a increment, right? So let's just get that going, and I'm going to increment count to 1. And also one other thing that I'm going to specify upsert to true in case if my collection doesn't exist, so that it just works. That's all I need to do, okay, for the logic that I'm implementing here. And of course, this logic could be way more sophisticated. So I'm going to save this function here. And now, as I go back to my collection, I'm going to insert a document using Data Explorer. So hello, Atlanta. And pay close attention. Notice here, I only had in my foo database bar collection. So ideally, if everything works, I should get a new collection that will show up if I refresh. That will give me the, okay, if I'm connected. So any moment, oh, there we go. Now I've got the counter. Here you go. Everybody sees that. And my count is right there. Okay? So that's how easy it is for you to set up triggers. You can even do more interesting stuff. You asked us to give you the ability to define triggers that run on the cadence. So you can actually specify a trigger that we call schedule trigger, where you can go choose the basic one or advanced, and you can pretty much specify like a cron job, and it will do just that. Okay? So let's go back to the slides. That's your Stitch triggers. Some of the use cases when Stitch triggers become extremely useful. Think of some IoT scenario. You get some data from a sensor, and you want the result of it to update some big dashboard. Perfectly fine scenario for this. Or you are shipping something from your warehouse, and you want to get an email system to send a notification to the end user. There's another example. Another example is that when you have some updates to the database and you want to put it on another distributed queue where it's a Kafka or, I don't know, Kinesis or whatever you have. And then the fourth one is essentially what I showed you, where the updates to one database, to one collection, result in some kind of an updates that are triggered in another database. So triggers are available as of 4.0, and scheduled triggers we released a few weeks back. So both of these things are available to you now. Pretty powerful stuff. Great. So what we talked about in distributed systems, we talked about global clusters, we talked about the industry-leading SLA, we talked about the triggers. Last one, we're going to talk about running everywhere, okay? And the important thing to remind everybody is that MongoDB Atlas is available in all 3 clouds, and we have a pretty generous free tier. Not a trial, but a free tier. So you can run in that free tier forever on all 3 clouds: Azure, Google Cloud, AWS. And starting recently, we actually got VPC peering available in all 3 clouds as well. So again, AWS VPC peering has been supported for a few number of years. Now we actually got it on Azure and Google as well. And the last announcement that I want to make is that we've got the ability for you to bring in your own key management service in all 3 clouds as well. So that's great. Now, one thing that I'm going to mention what we're working on, so this is more of a future, is cross-cloud. So having a database where you actually data gets replicated across multiple cloud providers, not just multiple regions, but across multiple regions and multiple cloud providers. And why would you want to do that? Okay, by the way, this is something that I'm only aware MongoDB is working on today. So one of the reasons you want to do that is, of course, because of the vendor lock-in. Here you don't have one, right? So optionality is the name of the game. Another reason is that, hey, maybe you are very happy with Azure, but there's one region that AWS has somewhere that you really want to take advantage of. So in this case, you can absolutely add additional regions that other providers give you. And the third option is actually more interesting, where you may be predominantly running on AWS, but you want to take advantage of one service that is actually led by Google, say TensorFlow. And in that case, you want to have the data that you're going to run your models automatically replicated into a Google region. So in this case, it makes perfect sense to do the cross-cloud clusters. This is something that's coming soon. Please stay tuned. That's public cloud. What about private cloud? What if you're not in the cloud yet, right? Well, you want to play as well, right? And of course, today, the way people play in the private cloud is by use of the Kubernetes. So we're supporting you as well. We're providing you with a MongoDB Kubernetes operator that basically allows you to drive through the ops manager the entire infrastructure deployment of MongoDB and feel good about it. So that's your runs anywhere. The last piece of running everywhere that I need to mention, because we talked about the public cloud, private cloud, talked about laptops, of course, is, of course, you cannot conclude the story without talking about mobile, right? So let's say you've got this piece of code. Now, this one does some barcode reading and analysis. And in the old days, you can imagine how, from your phone, you would be sending it to some application server somewhere to do that analysis. Now, it doesn't make sense, right? Because if you're analyzing, you're reading the barcode, you actually want to do it on the phone. And that's what mobile developers do today. So you want to run exactly that code on your iPhone or whatever, Android, on your mobile phone. And that's what MongoDB Mobile does. We launched it at 4.0. And we do have a dedicated talk today that I invite you to attend on MongoDB Mobile, bringing the power of MongoDB and talking about MongoDB embedded as well. And the important part of the mobile story, okay? The important part of the mobile story is how do you sync the data from your device, right, with the backend database. So we have a MongoDB sync service, and you can imagine that the sync would work like so, right? So you provide the document that you want to sync. You provide, importantly, the conflict resolver, because again, we don't want to be deciding this for you. The developer can choose how to resolve conflicts. Either the last one wins, or you may even choose to ask the user, right? And the architecture of how the sync would work looks like this, okay? It's all still driven by Stitch. You have the bidirectional chain streams going on, and it's something that I highly recommend you to try out. But there's one thing that you've probably seen in the announcements. Maybe you haven't, but just I think this week or last week, we've announced that we have gotten in the agreement to acquire Realm. And Realm is the leading mobile database. So I'm not going to be making any announcements or demos about Realm today, but there will be a lot of exciting stuff and the nicely integrated story presented at MongoDB World. So here's another plug for you to attend our flagship event in New York in June. So here you have it. We talked about the cross-cloud, that's exciting in the last tenet. We talked about the Kubernetes operator and support for Kubernetes. There's also free tier in every public cloud, and the mobile sync in beta. In Stitch, we have delivered query anywhere service, Stitch functions, Stitch triggers, schedule triggers, as well as the mobile sync beta that I talked about, and the support for global applications and ability to actually reference multiple clusters from a single app. And in Atlas, we've got some unique and novel things as well. So charts, global clusters, free tier on every public cloud, as I said earlier. Enterprise security features, I haven't spent much time on it, but again, we're supporting full auditing. We're supporting LDAP. We're HIPAA compliant. And there's others like ISO and PCI certifications that are coming in too. So we're signing business agreements as well. So as far as the enterprise security is concerned, we do take it very, very seriously. There's an industry-leading SLA. And the last thing also, we have the dedicated analytics nodes. Okay, and that's important. If you want to specifically pick a node, that can never be elected as a primary. Okay? You want to be very, very careful so that you do not impact your transactional loads. You can actually designate a node in Atlas as an analytical node. Okay? And of course, last but not least, in the core, in the database itself, we have done a lot of improvements. A couple of things to mention. We have recently GA'd a new native Go driver. So if you're a Go developer, you're going to welcome that. We've made a bunch of query enhancements, and we're doing even more for 4.2. And there's also free monitoring that you can set up directly through your shell, regardless whether you're using Atlas or not. Even if you're on-prem, you can set up free monitoring. It's awesome. And last but not least, multi-document ACID transactions, global transactions that are going to be available in 4.2. So hopefully, with all of this, arguments and all of these kind of quick lap around the new features and what we've been working on and the demos that you've seen today, I was able to convince you that we are, in fact, the best database for building modern applications for any kind of use case that is imaginable on any platform. Thank you very much. Enjoy the rest of the day. And I'll be around. We have experts. We have lots of exciting stuff. So the coffee break is in the hall.